video, we are just going to understand what is computer vision and what are its applications. So nowadays, people are talking about computer vision often, right? So it is fast advancing technology and it is playing a crucial part in artificial intelligence. So you need to enhance your knowledge of basic image or video processing algorithms to understand how computer vision works. And we are going to develop some projects so that we can improve our skills on computer vision. So due to the advancements in the new technologies, our lives are changing for the better as we see it. And a huge part of credit belongs to artificial intelligence and the wonders it is creating. What was once only in our imagination is now a living reality. Artificial intelligence, being rather new, has been already affecting our decision making and lifestyle on a daily basis. AI is now a part of every multi-billion-dollar company to every household. Whether you are on your smartphones, spending time on social media, or buying online products, listening to music, whatever we do, AI is impacting our enormous ways without us even realizing it. And out of that, computer vision is fast advancing technology that's playing a crucial part in artificial intelligence. So whenever we go to malls, have you ever wondered how the barcode reader at the mall is working? How does a simple device scan a bunch of black and white stripes and automatically input the price onto the computer? Or have you ever surprised with the smartphones of today, which is taking a selfie automatically when you look your best? Everything is happening because of the computer vision. So computer vision is basically an interdisciplinary field that deals with how computers can be made to gain a high-level understanding from digital images or videos. So what do we do with this computer vision? We can extract, analyze, and understand useful information from an individual image or a sequence of images. So it's a field of AI that works on enabling computers to see, identify, and process images in the same way that human vision does, and then provide the appropriate output. When you look at an image, immediately you could figure out that what it is. How do you do that? By looking at the features, you are interpreting that this is that feature. Or whenever you look into the videos, immediately you could recognize that. So what people are doing, what the persons are doing over there, what are they speaking, or else whenever you look into the image, you can identify about each and every object, right? So that is what being done by computer vision. It is a difficult task to enable computers to recognize images of different objects. So for better understanding, imagine whenever a machine processes raw visual input like a JPEG file or some camera feed, it is using computer vision to understand what it is seeing. So think of computer vision as a part of the human brain that processes the information received by the eyes, not the eyes themselves. So it is a theory behind AI systems that extract information from images. So computer vision seeks to apply its theories and models for the construction of computer vision systems. So subdomains of computer vision include scene reconstruction, event detection, video tracking, object recognition, 3D pose estimation, learning, indexing, motion estimation, and image restoration, etc. So, computer vision is a field of artificial intelligence that works on enabling computers to see, identify, and process images in the same way that human vision does, and then provide the appropriate output. It is basically an interdisciplinary field that deals with how computers can be made to gain a high level understanding from digital images or videos. So it is the same as imparting human intelligence and instincts into a computer. Now look at this image. Just I'm showing one of the application of computer vision. When you look at the image, what do? You may look over here and figure out that it is a traffic light. Here there is a traffic lights, right? And then cars, you can figure out there's a truck and there are some persons and there is a handbag. This is what we do, right? So can you just imagine the computer is also able to do that? It sounds interesting, right? So we will also make a model shortly, like how we can make the machine to understand or identify each objects. Now look at this. So here you can see a basket of fruits. So here you can see a basket of fruits, right? So look at this. This is a human vision system. So here is the eye and the brain. So eye is the sensing device responsible for capturing images of the environment, and the brain is interpreting device responsible for understanding the image content. Now we are identifying that there is a bowl with oranges, bananas, lemons, and peaches. Now look at this. Here there is the input, and here there is a sensing device and the interpreting device. So sensing device is nothing but the eye, and the interpreting device is the brain. And now what is the output? Bowl, oranges, bananas, lemons, and peaches. It looks great, right? So there are various applications of computer vision. What I have listed out here is actually very less. Optical character recognition, machine inspection, retail, automotive safety, match move, fingerprint recognition, or surveillance, and etc. So the concept of computer vision was first introduced in 1970s. Computer vision technology advanced enough to make these applications available to everyone at ease today. However, in recent years, the world witnessed a significant leap in technology that has put computer vision on the priority list of many industries. Now let us look into retail stores. How is computer vision being used in retail stores? You must have heard about Amazon Go, right? In this innovative retail store, there are no cashiers or checkout stations. No more waiting in line to pay the bills. It is a partially automated store, and by utilizing computer vision, deep learning, and sensor fusion, customers are able to simply exit the store with products of their choice and get charged for their purchases through their Amazon account. It's amazing. Then when we look into automotive, it is also used by automotive industry. There are some companies like Tesla have developed self-driving cars that are going to literally rule the streets in the coming years. There is no doubt about it. According to the World Health Organization, more than 1.25 million people die each year as a result of traffic incidents, and these cars promise to make our driving safer. So they are equipped with the sensors and software that can detect 360 degrees of movements of pedestrians, cyclists, roadwork, and other objects. So they are able to follow the traffic flow and regulations, and we can detect obstacles in its way. Then when we look about healthcare, well, we all know that computers can replace humans in doing what they do, especially in healthcare. But technology is helping healthcare professionals accurately classify conditions and illnesses by reducing and eliminating inaccurate diagnosis and thereby saving patients' lives. It's pretty good, right? So, one of the most recent and exciting medical procedures involving computer vision is a real time blood monitor by the Gauss Surgical Company that solves the problem of inaccurate blood loss measurement during injuries and surgeries. So, it also maximizes transfusions and recognizes hemorrhage better than the human eye. So there are always questions from people whether the computer vision is different from image processing. Both computer vision and image processing are based on the input of an image or signal and then processing the signal to give us the altered output. So as their names imply, their goals and methodologies, the boundaries, may seem clear. However, they draw heavily from the methodologies of one another, which can make the boundaries between the blurry and people confused between the two. Image processing is a subset of computer vision. A computer vision system uses the image processing algorithms to try and perform its functions. So in image processing, an image is processed. The image is bettered. It may have something to do with smoothing, sharpening, contrasting, stretching, etc. So it makes the image more enhancing and readable. So what is the goal of computer vision? So here we use computers to emulate human vision, including learning and being able to make inferences and take actions based on visual inputs. It is not limited to pixel-wise operations. It can be a lot more complex than image processing. So here the input can be images or it can be videos, and the output is not necessarily an image, but it can also be an qualitative or quantitative information like size, color, shape, or classification, etc. Therefore, the goal is to enhance the image for later use, then this may be called image processing. And if the goal is to recognize objects and provide useful information on it, then it can be called computer vision. Now, the next question that comes to your mind is, does computer vision technology involve machine learning? Again, there is a lot of overlap between computer vision and image processing, and the machine learning, on the other hand, is flexible as it can be used in both computer vision and image processing. So machine learning is an application of AI that provides systems with the ability to automatically learn and improve from experience without being explicitly programmed. So the goal of machine learning is to optimize differentiable parameters so that a certain loss or cost function is minimized. So machine learning can be used in both image processing and computer vision, but it is found to be more useful in computer vision than in image processing. So computer vision has the power of complex image processing techniques to extract meaningful features from a given image or video samples, whereas machine learning deals with pattern recognition and computational learning using some data prediction algorithms, artificial neural networks, etc. So there you may get another question like, how can I develop my skills in computer vision? So first of all, we should make our basics right. And then like we should master, or we should have some knowledge on digital image processing. And then when we talk about computer vision, once we have done with the digital image processing, the next step is to understand the mathematical model underlying the formulation of variety of applications of image and video content, and then bring in Python and the open source. So we will be using many packages like OpenCV, PIL, and there are several more platforms and packages, and then machine learning and convolutional nets. So the core idea is to teach a computer to learn concepts using data without being explicitly programmed. So I think now you are clear with what is computer vision, how is it being different from image processing and machine learning, and what are the skills uh, that are required no, to get ourselves involved in computer vision technology. And I think this is very clear to you.